Hello and welcome to our Group 3 group presentation for TSAL. For this project, our group have performed classification on datasets about the hotels, MGM Grand and Bellagio Hotel, to categorize reviews into good or bad based on the written reviews through the use of a model that we trained. The file import node was used to import the dataset into our enterprise miner project. The data that our group has imported into the system was through text. Therefore, our delimiter was set to tab. I added the drop node to drop variables that were not important to use for decision tree. We dropped author location, hotel name and review date because they do not provide any significant information in predicting whether a review is good or bad. Next, we added the transform node to create a new target variable called bad review, and this is achieved by creating a new formula. As you can see, we created a new variable called bad review. It's a binary variable and the role is target. So our formula is ratings overall less than or equal to 2. So the 0 will represent overall rating less than or equal to 2 and 1 will represent overall rating more than 2. Next, we added a data partition to partition our data. We partition data into training, validation and test. Training data is used for preliminary model fitting. Validation data is used to prevent the modeling node from overfitting the training data and to compare models. Test data is used for the final assessment of the model. We put 50% for training, 40% for validation, and 10% for tests. Next is our text parsing node. We added synonyms and words to our stop list. For synonyms, we have added abbreviations like FLR, supposed to be floor. Most commonly used abbreviation in the review or AC, so we put the parent term to aircon. And then next, the stop list, we added few words. The stop list we added words like hotel and review, which do not add no value to the modeling. So next, we go on to our text filter. So our term weight was set to mutual information. So what mutual information is recommend for data where a target variable is present, like our bad review, and predicting modeling is the goal, where we use decision tree and probability tree. The maximum number of document is set to 2, as there's 2 types of reviews, one for MGM and another for Bellagio. After filtering, we've done text cluster. Text cluster node is used to cluster the mined text into disjoint sets of clusters and report on descriptive terms for those clusters. We use the expectation maximization algorithm to find maximum likelihood estimates of parameters in statistic models, where the model depends on unobserved latent variables. The hierarchical clustering algorithm was not used because it takes more time to form clusters and have lesser accuracy with both normalized and unnormalized data. The maximum number of clusters was set to 40. However, after running the node, we determined that there's only 3 clusters were formed. These clusters associate words that appear the most in each entry together, such as words under the descriptive terms of cluster ID 1. The words in cluster ID 1 are usually about a hotel room or stay and administrative matters like check-in or check-out. As this cluster has the highest frequency, we can assume that most customers care about a hotel room or stay and administrative matters. Next, we will do our modeling. So first model we did was decision tree. Our assessment measure is set to decision, the default. So decision tree node was used to create a predictive model to establish which variables affected the bad review target variable the most. The variables used were the different types of ratings. The rating cleanliness, the rating locations, room service, sleep value, sleep quality and value. The variables, the node was run without any external changes to create an automatic decision tree. After running the node, these are the results. As you can see, for the decision tree, the node was split into rating service less than 2.5 or more than equal to 2.5. Which means most of the customers who wrote a bad review gave the hotel an average of 3 or more for their services. As you can see, for 95% gave 0 even though their rating service is more than 2.5. Therefore, we can conclude there's other reasons why the customer gave the hotel a bad review. The variables are judged based on variable importance, as seen from here. The variable importance, the rating service has the highest importance to bad reviews at the value of 1, while the variable imputed ratings location has the lowest importance to bad reviews. Therefore, the variable imputed rating service has the highest influence in predicting whether a bad review is 0 or 1. The next model we used was probability tree. We changed the assessment measure to average square error, and we use the exact same variables as we use for decision tree. From the results, also in this probability tree, we can identify that rating service is the strongest predictor for identifying whether a review is good or not. We can conclude that customers base their opinions mostly on the hotel service. From both of the trees, hotels can use this information to increase their quality of service to improve customer satisfaction. Before we do our regression, we explored to check for missing data in our stat explore node. And the results, we found that there was a lot of missing data. So we had to impute the data before we do a regression. So we imputed the data by their means so that we are able to use regression models for this task. In Enterprise Miner, regression models ignore observations that contain missing values, thus reducing the size of the training dataset and weakening these predictive models. So now you do our stepwise regression. Our regression type is logistic because our target variable is binary, and the selection model is stepwise. So from the results, so to find the results, we go to summary. So regression model selects and eliminates variables simultaneously based on both entry and stay significant level of 0.05. As you can see, ratings location was not selected based on the entry significant level. And the regression equation for stepwise regression is the y equals to intercept plus the estimate of ratings cleanliness times ratings cleanliness. Then, so the equation will be 5.6373 minus 0.4453 times imputed rating cleanliness minus 0.3405 times imputed ratings room minus 0.7535 times imputed rating services minus 0.6948 times imputed. Next, we do our forward selection. On forward selection, the regression type is still logistic because our target variable is binary and the selection model is forward. So from the summary, you can find out that in the second regression model we use is the forward selection. So how the forward selection, the model selects the variable based on the entry significant level from the results. results, we can see that ratings location was not added because it did not meet the 0.05 entry significant level. The regression equation for follow selection is the same as stepwise regression. So after doing our modeling, we'll be doing the model comparison to check which one is the best model to use. And based on the results, the best model is the stepwise regression model. It was chosen based on the valid misclassification rate, as it has the lowest misclassification rate, since our target variable is binary. To determine the performance of our model, we use the test results. The test partition is employed to evaluate the performance of the model. In this case, the valid misclassification rate for stepwise regression is closer to the test misclassification rate compared to the decision tree and probability tree models. This means that stepwise regression model is the most accurate in predicting whether a review is good or not. Thank you.